All right, so I think this is recording. Let's take a look at problem number 32 of our Scale 3 review packet. Scale 3 was relations of functions. This is asking me to, it's given a function and asked me to find the inverse. Because we had looked at our function transformations and we are familiar with a library of functions, that we know that this parent function, or we should know, that it's the cube root function. And the cube root function, the graph looks something like this, where it's definitely a function because it passes a vertical line test, but I already knew that it would. And it passes the horizontal line test, so I know this function is a one-to-one function. So this inverse they're asking me to find, I know that that inverse will also be a one-to-one function. All right, so let's do that. So let's use our familiar x and y notation. And the idea of an inverse is that the functions undo each other, and that's accomplished by switching the domain and range. So if we switch the domain and range, what we're doing is switching the x's and the y's. So for our equation, let's come in and do that. Everywhere we see a y, we write x. Where we see x, we write a y. So now we need to algebraically solve this equation for y. We need to get y by itself. Well, right now, the y is underneath this radical, so I need to get rid of this radical so that I can get that y by itself. So I need to cube both sides of the equation to balance it. And when I do that, on the left I have x cubed, but on the right, now the cube root cubed, the radical goes away, and I just have 3y plus 2. So I can subtract 2 from each side because of these two terms. This first term is the one that has my variable of interest. So I subtract 2 from each side to get it by itself. And now the y is of interest in these two factors. To get rid of this other factor, I divide by 3. And so I have x cubed minus 2 over 3. If you'd like, you can write it more in a form where you could identify your transformations so that you can kind of verify or think about the graph. When you have a fraction and you want to split it into two or more fractions, every term gets divided by that denominator, not just your favorite term. So I have x cubed that's being divided by 3 minus 2/3. So I know that this is a transformation on my cubing function, which looks like this, and the transformations are all on the y coordinate. There's a vertical shrink by 1/3, and then minus 2/3, it's going down 2/3 of a unit, so it's just going down a little bit. So if you were to graph the original function and graph this function, you would see that they're symmetric across the line y equals x because they're inverses of each other, and we also see that they're both one-to-one functions. If I want, I can come in and use the inverse notation. This is not an exponent. This is just indicating that this function is the inverse of f, and you could have left it as x cubed minus 2 over 3, but I just thought that you might want to try to relate it to things that you previously learned. So here is my final answer, and I hope that helps. Talk to you later.